So now we've demonstrated how the PID controller will affect the pressure. So this is an IP converter. I is current, P stands for, I stands for current, P stands for pressure. So current is converted to pressure. The pressure then, so lower pressure will relieve the valve, higher pressure will close the valve. Now it's important to note that this pressure was using a screwdriver here, a flathead screwdriver, has made a default pressure of 9 psi, meaning there's always constantly a 9 psi with no current. Okay, that's our lowest pressure that we're going to go to. We can lower it or raise our default pressure, but right now we're going to leave it at 9. So right now at 9, there's some water flowing, if you go through the pipe channels, flowing into the heat exchanger, okay? And there's some water flowing back into the bypass, right? If we increase the pressure using our PID, we increase the pressure, that means this three-way valve will close, closing the flow rate of the heat exchanger and increasing the flow rate of the bypass, okay? And then when we relieve the pressure, the flow rate of the bypass will go down and the flow rate of the heat exchanger will increase, right? And so we will do this now. I will raise this to 100. First thing you want to notice is our bypass is here, right? And this is marked, I'm sorry, our heat exchanger is at about 0.4 gallons per minute here. And if we notice our bypass flow rate is about 3 gallons per minute here, okay? When I increase this, you will see that the pressure will drop and the bypass will increase. So I'm going to increase it now to 100, like so. And it'll take just a moment because it takes some time. Right, totally drops. And as you notice, now it was at 3, now this is at 3.5 back into the bypass filter, going back into the tank, okay? And you can see in our PID, we're at 97.9% and roughly at 19.5 milliamps of current.